Hello everyone. Let us get started with C++ certification training. So the topics that we are going to cover in this discussion is what is a standard template library. Then we'll talk about various components of STL. Then we look at containers, and then we will look at what are the types of containers, what are the applications of containers, what are vectors, what are various member functions of vectors, what is a vector iterator. We will look at what are vector modifiers, and then finally what are vector capacity. So let's start with understanding what is a standard template library, or STL as you might call it. So what is an STL? STL is a set of general purpose classes and functions which are mainly used for storing and processing data. So basically in any programming language there is a lot of data involved. You have to store the data, process the data. That is where STL comes into picture. So STL can be defined as library of container classes, algorithms and iterators. So basically STL is a combination of containers which holds the data. Algorithms are basically the programming logic or the algorithm logic that work on their data, and iterators are basically used to access those data which are stored in the container. Then the idea to reuse already written and tested component which are defined in STLs. So basically there are already inbuilt STLs available. Of course you can create your own, but the ones that are already written for you or built and written for you, that can be reused. Why do we do that? It helps to save time and effort and enhance the quality of program. Since you are reusing the code, it will save you a lot of time and effort. And of course, the quality is improving because the STLs that are already written has been tried and tested by different developers and programmers over a period of time. So if you think or want to see it as diagrammatically, you can see that you have a standard template library represented by this image here, which contains classes and functions. Now, what are the various components of STL? So let us look at three major or key components of STL. One is container, another is algorithm, and another is iterator. So first of all, what is a container? Container are the objects that store data of similar type. So container is basically a location, you might call it, or a memory address, you might call it, where you store your data. So it constitutes a container. For example, you can have a list, you can have a vector that becomes a container in case of STL, for example. Then we have algorithm. What is an algorithm? Algorithm are procedures that are used to operate upon containers and manipulate them. So basically, as I had told earlier, that we have some algorithms written. Those algorithms can work on the data that is stored in the container. That is where algorithms come into picture. Then we have iterator. What is an iterator? Iterator behaves like pointers and are used to access the container element. So basically, if container is the place to store the data and algorithm is the logic that is applied on that data, then iterator is a reference or a pointer to that particular data with which you access those elements and basically perform operations on those elements. So let us continue with our components of STL discussion. Now the relationship between the three core components of STL can be represented diagrammatically, as you can see in front of here. So container stores all the data. This is your container. Then algorithms perform operation on the container with the help of iterator. As I've already mentioned, that you access the elements with the help of iterators. And finally, iterators are responsible for connecting algorithms and containers and enabling manipulation of data stored in the container. So basically, it is with the help of the iterator, you access the data that is stored in the container and perform or apply the algorithmic logic on those values stored in the container. So this is how the three core components of STLs are related with each other. So let us now continue our discussion on container in a little bit more details. So now, what are containers? Now, containers are objects that store related objects. So basically, when I say related meaning, suppose you have a collection of students. Now, students are related in sense that it is a similar set of data which is students, or rather you can have a collection of maybe integers which are stored in a container, or different data types. So basically the emphasis here is we store related objects which has a relationship or some kind of a relation with each other. So containers are objects that store some other related objects. Now they organize data in the memory and are implemented using template classes. So they organize the data internally in the memory, and this implementation internally is facilitated with the help of template classes in CPP. Now STL can be grouped in three major categories. We have sequence container, we have associative container, and we have derived container. So under sequence we have vector, DQ, and list. Then under associative we have set, multiset, map, multimap, and under derived container we have stack, queue, and priority queue. So let us look at each one of them one by one. So what is a sequence container? Sequence containers are homogeneous elements in sequential order. So when you say homogeneous, it means similar kind of a data, and sequential order means it follows a specific order or a specific sequence. So under this category, we have vector, we have DQ, and we have list. So let us discuss about each one of them one by one. So what is a vector? Now vector can be defined as a dynamic array. Dynamic because it can resize itself. Then here the elements are stored contiguously and can be accessed randomly. So the data which is stored in the vector are stored in a contiguous memory location, and you have an ability to access the elements randomly, meaning that you don't have to follow sequence that go to first element and then go to second and go to third. If you want to go to third element, you can directly access that third element. That is known as randomly accessing the elements within a vector. Then what is DQ? It is double-ended queue, and it is a container where insertion and deletion is possible at both the ends. So in a queue, you insert data from one end and also insert the data at another end as well. Now it allows random access of elements and is dynamic in size. Similar to the vector, you can randomly access the data from the DQ, and also it is dynamic in nature. Then we have a list. What is a list? List is a container that allows bidirectional access of elements and fast insertion and deletion anywhere in the container. So as the point specifies, or it makes it clear, then you can access in both the direction, front and back. I mean, you can move forward and move backward while accessing the elements of a list. Plus, when you do an insertion from a list or deletion from a list, it is very, very fast. And we shall see in some time why is the insertion and deletion very fast in the case of a list. So that is regarding the sequence container, under which we have vector, DQ, and list. Now let us look at associative containers. So in associative containers, elements are stored in predefined order and not sequentially. Here elements are accessed directly using their keys. So earlier, as we talked, that the elements are stored in sequential order, wherein in the case of associative container, the order is predefined and it is not sequential in nature. So basically there are four types here. We have set. Set consists of unique elements. So basically if you think of a set as a set of numbers, it will store only unique numbers. There are no duplicates allowed in a set. So therefore it is called unique elements. The value of elements cannot be modified once it is added to a set. So once you have put in a value, you cannot just go about changing the value of that particular entry within a set. Then we have multiset. Multiset is a set, but it can store multiple elements having the same value. So going a step forward, in multiset is an enhanced set, you might call it, wherein you can have multiple elements having the same value. So basically duplicates are allowed in the case access that value with the help of a key. So it's a key value relationship. Then we have a multi-map. Look at what is a derived container. Derived containers are also known as container adapters. So we have basically three types under this. We have stack, we have a queue, and we have a priority queue. So what is a stack? We all know that it is a container that follows last in first out, also known as LIFO approach. New elements are added and removed at the same end. So when you put an element in a stack, if you want to remove it, that is the one which will get removed from the stack. So it's a last in first out approach or principle used in the case of a stack. Then we have queue. What is a queue? It's a container that follows first in first out mechanism. Now here elements are added at one end and removed at the front of the container. So in the case of queue, you add element in the one end and from other end it will get removed. That is a queue, and it follows the approach of first in first out principle or mechanism. Then we also have a priority queue. So in priority queue, it is a queue where each element has a fixed priority and the first element always has the highest priority. So whenever you put an element, it is assigned a priority, and in case it is a first element going in the priority queue, it becomes the element with the highest priority. So these are the various containers that are under derived container category. Now let us look at applications of containers about which we have already talked. We'll look at it with an example. Now there are various containers available in STL, but considering the scope of our discussion, we are only going to discuss or consider some of the most famous containers that are available in CPP. So let us get started with a vector. Now vector is one of the most widely used container. It supports dynamic array, hence memory is allocated at the runtime and the size can be changed accordingly. So this point I had discussed earlier as well, that vector is dynamically resizable and the elements are stored in contiguous memory location and can be accessed directly. So directly meaning that you can simply access it with the help of index, and it's very easy, and you can even randomly access the elements of a given vector. Now as you can see in this example here, in the main I have created a vector which is holding integer data type. Inside angle bracket I have defined int and I have given the name of the vector as v. Now this code will create a blank vector and no size is mentioned. In the other case, what I have done is I have created a vector in which I have specified integer type to be stored and I have given 4 integer elements 1, 2, 3, 4. So in this particular case, a vector will be created having size 4, as you can see here, which a size 4 meaning it can hold 4 integers. So this is how we basically create vectors in CPP. So as the data is added to the vector, it grows in size dynamically. So as I have already mentioned that it is dynamic in nature. So if you add an element in a vector, the size will grow dynamically. Dynamically meaning runtime while the program is in execution. So this is how a vector works. We shall look at all of this with the help of example in some time in our further discussions. Then next we have list. List is used to implement doubly linked list, which allows insertion and deletion of elements from anywhere in the list, which is not possible in the case of vectors, although they do not allow contiguous memory allocation. So list is similar to doubly linked list. Now doubly linked list, they have pointers. So when you insert an element in a list, actual insertion and deletion does not happen, but there is a pointer which is readjusted, and therefore the insertion and deletion is very fast. I mean, insertion or deleting an element does not actually insert or delete an element from the list, but pointer are repointed to the new elements and adjusted accordingly, and this operation happens very, very fast, and therefore the insertion and deletion in the list is very fast. Now a syntax for creating a new list can look like this. I can say std : list int, this int is the data type, and l. So this is creating a list for me. Similarly, if you want to create a list with an elements in this, you can see here that similar to vector and arrays, list can also be initialized with parameters. So here I am creating a list holding 3 integers 1, 2, and 3. So let us now look at map. Now map is a sequence of key value pair where each value is accessed by unique key associated with it. The value associated with keys can be modified, but the keys are not allowed to be modified. So let's say if I have a key value pair, a key could be an employee ID. Maybe if you are working in an organization, your employee ID could be a key, and a value could be another object which is storing information related to that particular employee. So it could be your name, it could be your designation, it could be your role, right? So in that map, you have an employee ID as your key and the related information stored as an object, which is a value, right? Now your employee ID is going to remain same always as long as you're in the company, but the value in those object which is stored against the key can change, meaning that with time your designation can change, your salary can change. So basically key remains same, but the values, corresponding value can get modified. So that is the primary feature of a map. So map can be created using following statement. You create a map map, then you specify the key or the key type and the value type, and you give the name of the map, for example. So a map is commonly called an associative array. This is a commonly used name in the case of a map. So against a key, you store a value in the map. So like this, you can have multiple keys and you can store a single value against a given key. And this key value pair is unique in nature. What are vectors? So we will go through these points to understand vectors in more details. So vectors are the same as dynamic array. Dynamic means which can resize itself. So they can resize themselves automatically when an element is inserted or deleted depending on the need for the task to be executed, where the storage of vector is handled automatically by the container. So as you can see that this particular statement clearly states that if you insert a value in the vector and if it does not have enough space to hold that element, the vector size will be resized, or let's say it will be increased. And therefore, as you have seen in the statement, that it is dynamic in nature, it will resize. So if you delete an element, it can shrink in size. If you need to add more elements, it will increase in size. So let us look at some important points of vectors. Vectors are the most important container in C++ standard template library. Now, in vectors, elements are stored in sequential manner, so they can be accessed using iterators. So sequential manner meaning, let's say if this was a cell or rather an array, or let's say blocks, and these blocks are put next to each other. So this is, let's say 1, 2, 3, 4, 5. So they are sequential in nature, they are one after the another. So in vector, elements are stored in sequential manner. So if you put an element, let's say characters A, B, C, D, A, B, C, D, E. So these are stored in sequential manner in a vector. Now, unlike an array where only given number of values can be stored, vector can grow and shrink at runtime. So this I have already explained to you earlier that they are dynamic in nature. So depending upon whether you want to add more elements, it can either grow in size, or if you want to remove elements from vector, it can shrink in the size. Now element can be inserted at the end of vector container. So taking the original example which I had just explained to you. So in case if this was a vector for you and you have element A here, B here, C here, D here, you can add more elements at the end of this particular vector here. So elements can be inserted at the end of vector container. Also, vector has a lot of functions to perform operations, like you can sort the elements in vector. You can do reverse sorting. For example, you can pop the element out of the vector. You can push elements within the vector. You can find the size of the vector. And there are a lot more functions that are available to you to perform various operations on the vector. Also, vectors are very efficient in terms of performance. So all these operations which you are trying to do in terms of sorting, reversing, popping, pushing, deleting, all these operations, they can impact the performance of the program. But the internal implementation of vector is such that you will have a very good performance in spite of performing all these operations with the help of methods that are provided in the vector. So vectors are very efficient in terms of performance as well. Now, what is the syntax to create a vector? As you can see here, you say vector, you define the type of object maybe, or a type of data here, and the name of variable. So if you want to say vector, you will say vector int, for example, open bracket, close bracket, and you can say here a variable name v1. So basically what is happening is you are creating a vector which can hold integer values, and the name of the vector is v1. So vector is basically a container to hold values. Now this has been explained with an example here, as you can see below, and also this is a representation of a vector, as you can see, which is holding decimal numbers 1, 2, 3, 4, 5, 6 here. So these are stored in sequential manner. This is one, then next, then next, then next, then next. So they are stored in sequential manner, and you have an option which we will see in some time in next few slides, that you can access the first element and the last element and the subsequent elements in between these first and last with the help of iterators. So moving on, let us look at what are some of the member functions of vector. Now this is a very exhaustive list, and I have taken number of functions or a subset of functions and shown here for your reference. I have taken it from this particular URL or website. Now iterators, if you define an iterator on a vector, it has good number of functions. As you can see, for capacity you have good number of functions, for modifier you have good number of functions. So we cannot cover all of them, but of course we will look at few of them. For example, begin is to return an iterator at the beginning. So if this was a vector here, let's say for example this is a vector and it is having, let's say, 4 elements A, B and C. A, B, C and D. Begin will point you to the beginning of the vector and returns iterator at the end of the vector. So like this, you have other types as well, other member functions, like to find capacity. This is to check whether the container, which in this case is a vector, whether it is empty or not. Size is there, returns the number of elements. So like this, you have few others as well in capacity. Then we have modifiers. Now what does clear do? Clear will clear the content, or it will remove all the contents within this vector, for example. So insert is basically to insert an element. So like this, you have lot of member functions that are available in vector, and we shall look at some of them with an example also. So let us look at this example in the slide. We'll cover this example on our VMs also. But before that, let's briefly understand this piece of code in front of you. So here I'm making use of two functions, which is begin and end. Begin function returns an iterator that points to the first element in the vector. So if this was a vector, let's say I have this vector here again. So I'm putting few elements here, 10, 9, 8, 7, 6 and 5. So I'll put here 10, 9, 8, 7, 6 and 5. So what I'm doing is, this particular statement, it is a vector declaration. I'm saying that I want to create a vector which will hold integer data type, and the name of the vector is vector underscore example. Now what I'm doing is I'm running a for loop and putting in values in the vector. So initially when the vector was created, it was empty. So one by one I'm pushing the elements at the end of the vector. So vector will have first 10, then it will have 10 followed by 9. So this way, after this loop is executed, this is how the vector will look like. Now after that, what we are trying to do is I'm creating a begin and an end, or rather I'm making use of begin and end function. Basically this is a syntax to create an iterator which points to the beginning here. So let me go and clear some of this here. So if this was your vector, this auto I equal to vector example begin will point the vector in the beginning, and the end will point here. Now we can access the value of that particular element within the vector using star of I. You can see. So once we iterate through the vector using this iterator, it will display all the values from 10, 9, 8, 7, 6, 5, as you will see shortly with an example we will try. So basically this is an example of how we make use of vector iterator. So now let's move on and see some of the vector modifier. So what is a modifier? In this case we say pushback. Basically pushback functions insert an element from the end. So if we had a vector, for example, so if you assume this to be the beginning, this to be the end, insertion happens at the end. So what we are doing it here is we are declaring a vector and start to add element to that. After we do that, we create an for loop and display the elements one by one. Now after that, we made use of this method here. So if you will look carefully, we are trying to pop the element out of the vector. So if this was my vector, let's say, which had 10, 9, 8, 7, 6, 5 here. If I pop the elements, it will remove only this last element, and if you after that display the entries from the vector, you will see the output is going to be 10, 9, 8, 7, 6 and not 5 because it has already been popped from the container or the vector. So this is how we basically make use of some of the modifiers. Modifiers are the functions which modify the content of this container, which is a vector container in this particular case. So moving on, we will look at some capacity functions. So what are capacity functions? As you can see in the slide, we have size, we have capacity, we have resize function. So size returns the number of elements present in a current vector. Then capacity returns the size recently allocated to vector. And then you also have an option to resize it. So let's say we are declaring a vector here. After that, what we do is we are putting 10, 9, 8, 7, 6, 5 entries in the vector. So it is 6 elements we are putting. Now, if you try to go ahead and display the size, this will return you the number of elements in the vector, as you can see. Now, capacity returns the capacity of the vector. And then finally, you can resize it also. If you will resize it, the size shrinks to 4. So this is how you can make use of various capacity functions that are available in vector container. So let us head to our lab VMs and try all this with some examples. That's all in this discussion. Thank you so much for your time.